So welcome everyone. Today, SallyAnn and I will be talking about large content and behavior models to understand, simulate, and optimize content and behavior. So that's a little bit of a mouthful, but you might see like behavior is mentioned a few times in that sentence. And this is really about content, behavior, and understanding for large language models. So I'll get into the initial premise of the paper. So Claude Shannon and his seminal papers on information theory. So Claude Shannon, founder of information theory, cryptographer, he laid down a lot of the foundations for AI and the development of models and communication systems. He divided communication into three essential levels, where there's the technical, semantic, and effectiveness. And with the technical, essentially the technical barrier, just being able to kind of receive transmissions. Now, this was in the time before the internet when he proposed these three levels. So by having the web, various forms of communication, we do get the technical level of communication through. The semantic and effectiveness levels, for the folks in this paper that are using this theory to try to evaluate essentially the effectiveness of LLMs, they're saying the semantic part is largely solved for the understanding that LLMs can produce, but the effectiveness, or even effectiveness to mean like the impact you're having as a user, how you're feeling about like the information. For example, if you're engaging with a chatbot, like, are you enjoying your experience? Is it effective? Are you getting the answers that you need? That there's, not great effectiveness, or the effectiveness is a little muddled. It's hard to tell the effectiveness for these LLMs and what they're doing, and what they propose might be a reason that the effectiveness is at least hard to measure. Whether or not it is effective or not is a lack of what they're calling behavior tokens. So if there's underperformance for your LLMs, it's saying it could be a lack of these behavior tokens. Now they're defining these behavioral tokens as shares, likes, clicks, purchases, etc. But I think as folks come from industry and are like data scientists, machine learning engineers, they call these behavioral tokens feedback. So user feedback, this is like highly sought after user feedback for, are you giving a product 5 stars? Are you liking an ad you're seeing? Are you clicking on that ad? Are you adding an item to cart? Are you clicking to purchase that item? So these behavior tokens, as SallyAnn and I read this paper, coming from AI training, for us, this is user feedback that's really highly sought after, but is often sparse and is hard to come by. So it would make sense a lack of behavior tokens being a reason why LLMs may not perform optimally. Like if they don't have the feedback for a given task, it can be hard to make any personalization and any kind of customized result for users. Now, what they claim though is there's this issue of noise. So in information theory, you have the transmitter. So you have like information source, you have transmitter, you have a signal that goes out, and then you receive the signal. So you'll hear a receiver referred to a few times in this, and between the transmitter and receiver, you have noise that's coming in to the system, and you essentially always want to reduce noise. Now it's calling these behavioral tokens noise that get filtered out in the training process, which would be great to have someone from this team kind of offer feedback for exactly why they're treating behavior tokens as noise. Because for SallyAnn and I that work with a lot of clients in the space that are on these large organizations and are on teams that work for e-commerce sites, for example, it's hard to understand why behavioral tokens, why user feedback would be considered noise, but they're saying it's considered noise, and that's why a lack of behavior tokens, just aren't in the presence of these pre-trained LLMs. So essentially, LLMs are very generalizable. They don't have this user feedback of likes, shares, purchases. And so they create these what's called large content and behavior models, LCBMs. So kind of compact specific LLMs, like for a given use case. They create these to show particular behavior and better effectiveness. So what they're calling effectiveness. And the four benchmarks that they're using are behavior simulation, content simulation, content understanding, and behavior understanding. So these are areas that teams pay a lot of money in industry to collect this kind of feedback from users for behavior simulations. For example, one they have here is, I have two ad variants, A and B, which one will the user like? And it's hard if you just ask ChatGPT, I have these two variants, which one will the user like? It's going to be difficult for them to give that information if they didn't have any of these behavior tokens or have any user feedback to give an indication of, oh, variant A is better than variant B. And then you have a content situation, so simulation and understanding, where the content understanding, if you ask, what is the color of the wall behind the man in a video clip, for example, it needs to be able to understand the content that it's seeing, and then being able to understand behavior as well. So for example, what they have here in the behavioral understanding part, if 100,000 people viewed this food ad, why did only 500 people click on it? So being able to take in a clip, understand what it's seeing, and then infer behavior from it to try and get a better understanding of, oh, well, you showed this ad at night and generally, or you show this ad in the morning and generally people prefer to eat healthier in the morning. So if you showed it at night, that would be better. So different behavioral situations. So those are the four main benchmarks. SallyAnn, are there additional either charts or graphics that you think would be helpful for folks to understand further the concepts that they're trying to talk about in this paper?
Yeah, there's a few visual and some points that I think really add color to the process they went through to really observe the effects of adding in this behavior data. I think one thing to note is in the abstract and some of the things that Amber was mentioning, it's a lot of this. The first part is just kind of expressing why LLMs don't work now with the for these kind of behavior oriented tasks. And so what they're trying to do now is observe it by adding in this behavior data that's often considered noise when we're pre-training these models to do, their generalization tasks. And so this first one here just kind of highlights that the performance on this new LCBM model is better than our traditional models like our GPT 3.5 or GPT-4. So just kind of highlighting there that they did find results that these were better. But let's go down to this visual here, because I think this really highlights how that performance kind of comes into play. And so here we have an example of a frame. So we'll get into this in a little while about how they're actually passing this information to their LCBM. But this is just kind of a high level overview of the performance. So you can see here we have this frame. We have some comments that were given with this frame video, or the frame from the video, as well as some metadata. And then we're asking the question, why would the average sentiment of the comments of the audience be either positive, neutral, or negative, and explain why? And so you can see the various responses we got from different LLMs. And so their model here, you can see that it was able to identify the negative sentiment that was attached to the audience comments. And then it was able to give a really good, I think, explanation for why. And it was really able to hit on that they feel sympathy towards the man's situation. And that's, if you read through the column or the comments, that's exactly what they're commenting on, right? They feel bad, they feel sorry for him, they think that he was desperate. So it really is able to pick up on that using using this new model architecture. And so when we look at Vicuna and GPT 3.5, you can see that maybe it gets some of it, like Vicuna was able to get the feel sympathetic, but it wasn't able to pinpoint that they were negative, not both positive and negative. And kind of similar to that, GPT 3.5 really didn't give a very good answer. It didn't really pick up on these, that it was positive or negative. It thought it was exciting or thrilling. So it just overall was wrong. And so we can see how this LCBM is coming out on top in this situation. Very similarly here, except a little bit better results by the others. Again, same information that's sent, but now we're asking basically the same question. And then again, LCBM was able to get the positive and the reason why, and the others struggled. It looks like 3.5 did better here. So that's positive news, but still not as good as the LCBM model. So that's kind of the results. So we can see that it's coming out on top with their new process. And let's get into a little bit about how they're solving this effectiveness problem. So I'm going to go down here to, we'll come back to this visualization here to chat about how that relates to the Claude Shannon visual that we were showing earlier. But I want to point out this fact that we're doing this step of verbalization, which is how we're actually passing this information to the LLM. So we're taking videos, and for every video V, we're taking 100 retention values, and we're spreading that over the duration of the video. So it doesn't really matter how long the video is, it's always going to have 100 evenly spaced retention values, and each of these have a replay value associated with them, which signifies how often these parts were replayed. So that's kind of important too for them understanding the behavior of the video that the LLM is going to be analyzing. They also then select 2 random frames to send, and they caption this with blip, and they also use whisper to transcribe. And then finally, they encode the video frames with clip model, which is really important. We need those embeddings. That's the information that these LLMs can really make sense out of. So that's a super important one. And then they're going to verbalize that behavior data. And we'll scroll down to the example so you can see exactly what that looks like. So here is kind of where we can see some of that behavior data. We have, this is a channel, so they're using videos from YouTube, so they take in the channel information as well. We have a group of writers from Adobe, so you're going to see Adobe in here. So that's the channel they've chosen to use. And so they'll send like the title and how many subscribers, but they also show how many times it was viewed and liked. So that's adding in that behavior data to the model itself. And so kind of scrolling down to what this all looks like in the architecture. So this looks a little like alarming. You think this is a huge model, right? But it's actually kind of set of smaller models, and the LCBM has said that it is smaller. We don't know exactly the architecture, what they've done there based off the paper, but we do know that they claim it to be much, much smaller than our GPT 3.5s and GPT 4. But the thing I want to really point out here is all these beginning steps are essentially just to format and verbalize our data so that we can send it to our LLM. We can't just send in just like the frame and the video. We need this all to be verbalized. And so it's kind of this elaborate prompt engineering kind of workflow, if you can think about it that way, where we're taking in those different types of input and putting it into our prompt template in a way, and then passing it to our LLM to ask a question like before, like, why is the wall blue? Or why, maybe did they make that comment? So that, I think, is just the overall process of what they've done. And then we observed the results. And essentially what we found, or what they found, was that this change in process, this change in how we're sending the data to this content specific model has better results than if we were just to ask those questions to our standard foundation LLMs. So that's kind of the whole premise. I think it would be good to kind of maybe now circle back, now that we have the understanding of what they did, let's chat about this diagram here in comparison to the Claude Shannon diagram. And so I think it's really interesting to see these two things. Amber, I'm not sure about what your thoughts were on this, but I think it's just an overall really interesting research perspective. We see a lot of these papers coming out that are very focused on like, let's improve performance. And this one here is a little bit more abstract, in my opinion, where they're like, let's study LLMs under the umbrella of like communication and information science and see how that relates. And so it notes at the end, like there are many traditional ML applications that are doing this predictive behavior or this behavior prediction. Like you think of your recommender systems, like a lot of in e-commerce, things like that. That is all essentially predicting behavior for the desired outcome, except here they're just trying to apply it to LLMs. And so do you want to talk through how this diagram relates to the other one?
Yeah. And in my mind too, this is almost like information theory full circle where, when it was initially proposed, obviously none of this existed. This was the theory, a foundational theory to build all of these. And now, the folks that, laid out the groundwork for this paper decided to use it almost as a way to evaluate the effective communication for these large language models, which has been obviously very large topic. Like, how do we know that these models are performing well when, these are stochastic models? Each time you run them, you might get something slightly different. How do you make sure that the user is satisfied with these? And so by having a communicator and a receiver in this image, it looks like they don't put in like the noise aspect that they do in the Claude Shannon diagram, but you're still having the initial information that's going out, the place that the information is received, and then almost the interpretation of that information that was received. And for this example, I think it makes a lot of sense. And probably what we're going to chat more about is going to be around how most of the time when models like this are created, all that noise that they're referring to is, it's not the same kind of noise in information theory. It's incredibly important and almost the key things that folks want from those models. So when you're looking at the effect like likes, views, scene replays, all those do have predictions or tend to have predictions from historic data and from those behavior tokens, or what we would call performance metrics for that user feedback. So I think it's really interesting of in terms of information theory, drawing the parallels to it, because all those parallels helped create the technology that we're using today, and just have exponential impact on communication globally and putting education into the hands of people all around the world. So I do really like the parallels, and almost using information theory as a way to evaluate the effectiveness of LLM performance.
Yeah, it's really an interesting kind of view, like I mentioned before, of just from the research perspective. I think here, for me, when I read through this and I boiled down to what the goal was, and I think the goal was to identify whether or not the behavior data had meaning to it for the LLMs to predict behavior. And I think what they proved is, yes, okay, there is meaning in there. And I think what's interesting is what this means for the future. It's kind of, I think, almost like a POC for these behavior oriented ML use cases. Can we actually apply LLMs here instead of the traditional methods we're using? And so I think now it's going to need to optimize. You and I, we read that paper a few weeks ago on long content or context. And I look at this prompt here that we're sending, and that's a lot of information.
A lot of context. Yeah.
So I wonder, we saw good results, right? They saw that there was improved performance here, but then I start to wonder, should we maybe experiment with how we're sending in this context? Is it too much? Is some of it getting lost in the middle, like we saw in that paper? And so I would be interested to see, if they introduce some of these other optimization techniques rather than just focusing on this, one new model, what other potential benefits we would see. And I'll also be interested to see if the future pre-trained LLMs will start including this behavior data as part of the generalization pre-training task.
So do you feel that this model is almost just a use case specific model, that other teams in industry are also building their own use case specific models with this prompt engineering?
I do think that this is probably very use case specific. I would love to see kind of what's under the hood with this LCBM model. But I think it will be very specific to behavior prediction tasks. Like if you want to be able to predict how a user will react or behave with an email, that was an example they gave. Like if you were in marketing and you're sending out an email, you want to use the one that's maybe going to lead to the most clicks on the URL to then get them to your, website. And so like that could be an application where I see you'd want to use this, but I can't see this model having extremely better performance, if better at all, on more of the generalized tasks, like your generative, your chatbot, those kinds of use cases. I think like there's probably too much information in there that's just not needed if it like requires all that behavior, and it's going to be fine-tuned specifically through the lens of predicting behavior. So I think it is very use case specific.
Mm-hmm. And because it's interesting when we look at just the final thing we're seeing here, when the large content behavior model spits it out, it says the replay values, this video would have this many views. And so it's giving predictions or it's giving this prediction based on the inputs and outputs that it's previously seen. So all that ground truth data that is coming in from their behavior tokens. When we initially were reading this paper, we noticed that there's kind of no talk about RAG, which is being used a lot by teams. There was a paper reading on RAG, retrieval augmented generation. Do you think that, I know I'd be interested, do you think that RAG would have a similar performance, the way or the way teams can take certain relevant content, use that relevant content, and then use an LLM to kind of generate that response? What are your thoughts there?
Yeah, I mean, as soon as I read this paper, I was like, is there an easier way? Like, to me, this seems like a lot of work, right? So we find the videos, we have to encode them, we have to transcribe them, we then have to, verbalize all of the behavior data. I was thinking to myself, same thing, like, could this be a different use case? I'm not convinced RAG would be appropriate here, and I'll tell you why. It's because of the format of this behavior data that they're looking for, because they're attaching like one specific instance with their very specific behavior, where with the RAG system, we would need to use similarity, right, to retrieve those relevant pieces of information. So it would come down to like how we're formatting that in our vector database. I think it's possible. We've seen some amazing work be done with RAG. So like, I think it's possible, but I think if they were able to actually use what I would do, or I would be curious to do, is like take this data set of all this behavioral data and use an LLM to kind of generalize it, see if it can come up with some patterns around that, and then maybe we vectorize that and then maybe use that to power your RAG. But I think there would need to be some generalization and figuring out like what the patterns are with this behavior data before it could be used in that kind of system.
Okay. Yeah. Very, very interesting. Because with the behavior tokens, when they're talking about likes, purchases, everything that, essentially companies are trying to get and are trying to monitor in production. You said, is there a simpler way to do this, or, just wanting to ask the writers of this paper if they've considered other methods. What would you like to ask them in terms of, did they consider this option, or, what you would like to see in the future of the LCBM model compared to?
Yeah, I think that the big lingering question I had while reading this is kind of that so what kind of question. Of wanting to know, like, I know their motivation was to understand where LLMs are basically to observe the impact of including this behavior data with an LLM. And I just would love to understand, like, what's beyond that? Like, where do they see applications for this, use cases, what their real vision for this kind of technology would be? Because I think they even acknowledge themselves, we're still really far away from solving the effectiveness problem in the various communication levels. So I think that would be my number one question, is like, what do you visualize? And also, is it purely experimental then, or are we really trying to kind of reinvent the wheel? Because I'd love to ask you, Amber, like, we know that these systems exist and work really well in traditional LLM applications. Do you think it's worth, I don't, that's kind of a strong word, but do you think it's worth kind of bringing LLMs into this? But because the data itself is innately tabular, right? Like all this behavior data is tabular. So I'd be interested to see your thoughts on that too.
Yeah, I mean, it's interesting, especially like they're talking about the size comparison as well. They're saying, because they're using the largest parameter models here, the 100 billion parameters. I was kind of surprised that they didn't use Claude, because this is Claude Shannon's theory. And I'm curious how like constitutional AI, I think it's actually better at understanding behavior. And so I would be curious to see that, like maybe in a future comparison. But it's almost like comparing apples to oranges when you said, would this fare well against a generalization task for language that GPT-4 has been shown to be dominant for. And so the thing we always say to customers, right? It depends. It depends what you're really looking to get out of your model. And it does depend, like, do you have this set of behavioral tokens? They're using YouTube videos with, I think the one had hundreds of thousands of views that they showed in the very first example. So very well seen videos and content that have tangible feedback that they can get from that video and engagement metrics that they can already get from that video. Some teams are starting from scratch and they don't have that. And other teams have all that understanding. So they can essentially say, these are a lot of behavioral tokens and we can use it to do, and they've already been using it to kind of do this prompt engineering to really focus on their use case. So is it fully worth it to implement it as an LCBM? I don't know, but if anything, this paper does prove the effectiveness of prompt engineering and for these large language models in the same way that we reformat how we might talk about a given topic just because of how just the way words now play in the effectiveness and performance of these models. We're saying like the next language that everyone is learning for AI has been English and no longer just Python and frameworks.
For sure. And I think it's really interesting to see how this goes. I do think they also proved that there is value in including that behavior data in pre-training. I think that's kind of, again, the overall thesis there is like they're saying, these foundation models, they strip out the behavioral data because it's noise to them. We say it's not noise. It's important for predicting behavior, but again, it's all through that behavior lens. So it'll be really, really interesting to see where this goes next. I kind of was thinking through this. You mentioned it in the data sets that they use the YouTube videos. They use YouTube and emails from like the Enron email data set, essentially. So I would love to see some different data sets. They mentioned that unfortunately you have to rely a lot on simulated data in this kind of behavior prediction, which opts its own challenges, but I'd love to see this across, a variety of tasks and all underneath the behavior umbrella, but that's a really good point. But on that kind of thought, I'd love to hear what you think like a potential use case. Say we figured this out. We figured out, we unlocked a LLM that is able to predict behavior. Where do you see customers wanting to use this?
Yeah, I think if you could really develop that and it works really well, you would be able to make a lot of money because many customers would want that. And essentially, in terms of like user experience and user experience research, there's a lot of money that goes into just trying to get feedback from user behavior, and every user is going to be a bit different, but there would be a lot of applications for this. Every team that's doing e-commerce, any team that really wants feedback, there's been a lot of work on chatbots recently, and I think that would only be like the first stage kind of it, like, is this user going, if you could predict, like, if a user is going to be happy with the response of a chatbot, I think that would be like kind of like the baseline use case. But if you could predict, if you're Spotify and you could predict, like, with high certainty, if a user would play a song or like a song, or skip a song, like, there are so many models that are being developed for that kind of user behavior. And if this is better at like understanding the effectiveness, and if we can actually use these models to communicate better to our end users, that would be huge. And like, maybe it is tied into the effectiveness here. But yeah, just going back to what we've talked about, is it really noise is kind of the questions we've been asking. And, obviously those behavior tokens aren't going to be present for specific use cases in these very large models in GPT-4, which is expected. But I would be curious to see how this performs against the use case specific models. And if this did one for a specific use case, like predicting whether or not a user will click on an ad, or add an item to cart, or skip a song, I'd be really interested to see how that would compare.
Yeah. And they mentioned a few times of even about kind of eliciting a desired behavior. And that's another interesting kind of use case for this. Because, what you were just talking about is more like, okay, given this data, what do you think the user is going to do? Right. And there's also a side of this where it could potentially be more of a generative thing of like, we want to elicit this type of behavior, like what content should we put forward? And that's something that's interesting, but I think it kind of starts approaching that social and ethical, implications of this technology. And so I definitely think it's something that we should be mindful of as we continue forward in this kind of area of research. We've seen AI be harnessed to kind of do that type of, I'll call it malicious in this context here, of changing people's minds without them even realizing. And so I think it's something to definitely keep eyes on, but I'd love to get your thoughts on that. Do you think that's something that's we have to pay attention to, or you think that this is more focused, based off the paper, of course, is more focused on, predicting the probability of a behavior?
That's really interesting, SallyAnn. That's a good point. Because say you have a user's every behavior, and that they're more likely to online shop at 3 a.m. So you send them these coupons at odd hours, and the ethics behind it is a really good point, because we're calling them user performance or performance metrics or behavior tokens, but it's like these are how people act, and like these are their personal preferences and behaviors that we're using to make predictions on. And we're measuring like how accurate our predictions are, and it's very easy to just extract the information we need, and aren't thinking about the consumer as a person that maybe doesn't want all their behavior correctly predicted. And I'm thinking I think we both read a lot of sci-fi, and just thinking of like where that actually leads, if someone could still like do all those predictions. And if you watch Rick and Morty, it's like the heist episode, and where it's just all these predictions being made. And maybe I'm getting a little on the tangent side, but I kind of forget the initial question. But I think just being able to predict users' behavior, and then kind of like backtracking things so that everything's set up for that particular user. Like there's difference between personalization of just trying to get what the user actually wants like out of your site, and then trying to optimize everything to just keep selling. I guess that, totally right. Like that's a huge point on it. And the ethics, I think are things that need to be honestly debated like at higher ups for what companies are allowed to do with all user behavior and how to filter it into individual models. And I think Europe is a little bit ahead of us on some of those aspects.
Just a little bit. I would totally agree there. And it's interesting. I think there are a lot of people thinking about this, and I totally agree with you with that kind of the trade-off between like personalization and then like really augmenting the way people behave. And I think there's a clear distinction, and it'll be interesting as we see. To be clear, nobody's doing this currently, but with this kind of research that's going on, it was something that my brain immediately thought about, was like, okay, how does this interact with like our social structures and the ethics of it all? So something I'm personally really interested about is how we balance this, because I do believe there's obviously so much good in this kind of technology, but I think it's important that we all kind of always have that kind of angel and devil on the shoulder of being like, okay, this is really cool, but like, how do we make sure we're not harming real people, you know?
So I had a friend that worked at Walmart Labs, and she gave an example of showing that their prediction algorithms worked really well, but it wasn't the desired effect. So basically what happened, and this is like a well-known story kind of within like the AI team, Walmart happened a long time ago, but they basically a man called and I don't know, got into customer service. I got back to the AI team, like, why are you sending my daughter like all these like baby ads and all these ads for like infants and baby formula? Like, is it just because like she's, like a woman? Like, why are you sending all these? And then he ended up calling back later and saying like, actually she like was pregnant, like we didn't know, so sorry, like guess it was helpful. But they, based on her pattern of purchases, they had predicted that she was pregnant. So like buying, I don't know what the things were, but like buying tests, buying prenatal vitamins, buying these things, and then all of a sudden these coupons go to her, I think like whatever, emails listed, like address to her family's house. And because the predictions were so great, it's like, oh, well, she has all these, she's going to need these. And it's just like one unforeseen consequence of correctly predicting behavior so well. And that always stuck with me. I'm like, oh, that's very interesting, because like you're trying to help the user, but you also have to think about the ethics and what the user, what they need and what they want are maybe two different things.
For sure. I know we only have a few minutes left. There was one other thing I thought would be interesting for us to chat about, kind of switching gears drastically here. And this is just kind of a little anecdotal thought that I had about this. And it's on the fact that we do not 100% understand, right, the human brain and how all these interactions happen, how we actually make meaning from info. And do you think that we need to fully, or at least better understand that before we can expect ML to actually replicate communication here? Because that's essentially, what they're doing here.
Right. I mean, when you tell people you work in AI and they're like, how close are we? And then we're like, we can't even, figure out why someone is rage clicking on a site, So my opinion is, yes, we need a lot more understanding, but I don't think I can't see us ever fully getting there. It's my opinion on it. What are your thoughts, SallyAnn?
Yeah, I totally, like, not in our lifetime. I don't think they'll fully ever understand. I think I almost see a path where we're pivoting a little bit, like what we talk about, the attention mechanism in the LLMs and how that's causing issues. Before it was really great because then we were able to get that real NLP, kind of the NLG going. But now we're seeing like, okay, for these LLM applications that has like basically some issues associated with like the size and things like that. And so we're rethinking the way that we do that, but that was all based off of the way that humans pay attention, right? And so it's interesting. I wonder if now that we have this kind of solid ML foundation under us, if we start pivoting away from trying to replicate the human brain and kind of going back to maybe more like mathematical or statistical basis to our models. So it'll be really interesting. I don't have a clear-cut answer, but I'm excited to see how these kind of two fields grow in parallel to one another.
Yeah, I think the pivot's a good point, especially when you're making a purchase online. And this has happened to me before. Like I buy like a main product, let's say on Amazon, and don't realize like I need batteries, or like I need this like extension thing, or I need like another part of it. that like almost needs to be bundled. And so, yeah, I don't think it needs to mirror the human brain. Like it almost just needs to jump a few steps ahead of like, that need versus want. Like instead of me just thinking about like the next thing I want to buy in general, like what might I need to like go with this product and what have previous users used, and less trying to focus just on me and focus on, like maybe just what like general data tells us. Because sometimes it's it's even a little too strange now how much they know my preferences. So
yes, it can definitely be strange. And I think that brings up a good point where the generalization of these might have the edge over those traditional ML applications where, that they're predicting those specific kind of, next step of what you think they think you'll need. Whereas the generalization might address that problem you're having of like, okay, I'm buying something that needs batteries and I don't have batteries. So therefore I should probably add batteries. And that's kind of more of a general, just kind of instead of looking specifically at like what you purchased and what you might then want from there. So that's a really interesting point.
awesome. Well, maybe just we could close with, I'll just quickly say like what our final thoughts were on this. And I think we both really liked the angle that it took, about going all the way back to information theory and the fundamentals of communications and AI and technology, and then using that as a system to be like, maybe we can learn from this and evaluate against it. But we did have just like a few thoughts on, is this a completely like novel method, and is this behavioral token actually noise, or is it highly sought after performance metrics?
Yep.
And I'll plug one more time for Arize events, because I know our marketing team wants to drop that link in here. We have these paper readings, we have workshops coming up. SallyAnn, any closing thoughts before we end the session?
Not really. If you haven't read this paper, I definitely encourage you to check it out. It's a different, it's a change of pace from some of the other LLM papers that have been coming out. It's a different lens, different writing style. So I think it's definitely worth a read, and I'm super excited to see where they take this idea next.
Awesome. Thanks everyone for joining. Have a great rest of your week. Bye.
Bye.